Electricity can be really dangerous, but even though it could potentially kill them, loads of homeowners still decide to work on their own electrics. That's why today I'm going to create 5 electrical faults to show why electricity can be so deadly. Then it's going to be up to Reuben, the apprentice, to find the faults.
Interesting, very interesting.
So we're in Jordan's kitchen. I've installed 5 faults into this ring. Everything's on and working, and you wouldn't know to look at it. You can't see or hear any of these faults. Let's see if Reuben can find them. Okay, so pretend I'm the customer today.
Yeah.
What's happening is everything's working fine, but whenever I turn that lamp on, the electricity keeps tripping off.
Right, okay.
I don't know what's going on, so if you could have a look at that, that'd be great.
I'll have a look. So this lamp here?
Yeah.
I see. I see.
I'll be your glamorous assistant and pop that back on for you.
Thank you. So I suspect that the neutral and earth have been reversed.
So I'm going to be putting a cross in here between neutral and earth. So if you looked at this, you can quite clearly see they're in the wrong terminals.
Because as soon as a load's put on it, it's tripping. I'm just going to go around on the other sockets, do end-to-ends and a live test on them just to see if the others are the same or if they're okay. Okay. Alright. Okay. Okay.
Looking good so far?
I see you. Yeah?
So it's going to be a cheap bill for me, the customer.
Ah. Uh-huh.
What I'm going to do is I'm going to cross the polarity here. It's quite easy to do. Sometimes you'll be putting in sockets and they just swap between the 2 sockets you're putting on. If they're single pole and double pole, they can change sides. So it's a common mistake made. So I'm going to pop them over and Reuben should be able to find that quite easily. Live and neutral swapped over.
See, I actually don't know what this means on your tester.
That,
I'm guessing that's neutral live reverse.
it does mean that. So it won't carry out the test. It's warning you saying that there's
reverse polarity on this socket. Interesting, very interesting. Uh-huh. That's losing something, I'm guessing. Something's not right with this socket. I know that for sure. Okay, a bit higher than I would have thought. Oh, it's okay. Checks out. Okay,
So you've checked all of the sockets now. So
Yep.
what's your initial sort of impression of it? So you said there's a fault there.
Yeah, so there's a fault there. There's at least reverse polarity at that socket.
Yeah. So I said I put 5 faults in here.
Right.
And you think you found at least one?
1, 2, 3.
Okay.
As of now.
Would you like to see if you can correct at least one or 2 of them? And then we can go on from there.
Okay.
So you said you thought it was a neutral earth reverse here.
Because when there's a load on it, I imagine it's trying to send it back down the neutral, but it's just going through the earth, causing an imbalance.
That sounds very good. Sounds very good, isn't it?
Screw's a bit tough. Had its Weetabix. Oh, he definitely had 4 this morning. And then you cram 4 Weetabix into a bowl. Wait, can I just address the people who don't? Sorry, it's a bit of a sidetrack, but for the people who eat inconsistent number of Weetabix and then end up with 1 in the packet left, just stop buying Weetabix.
Yeah, you're not allowed anymore. Seriously, it's the most infuriating thing. Ooh,
Here we are. So, that is earth, but it's not. And this is neutral, but it's not. So as I predicted.
As Reuben was saying, so it's only when you make the plug, when it's actually plugged in, so the neutral is where its load is trying to go, so it goes through the appliance and it's coming back out, but that's then going down to earth, so the RCD is detecting an imbalance and taking the circuit out. In all honesty, this shouldn't be something that should be happening on a regular. However, if this was a unprotected circuit, so it had no RCD, it would work perfectly fine and you'd never know about it, because neutral and earth are at the same potential. In a modern board, it should be picked up as soon as something's plugged in, but it's an easy mistake to make. So any DIYers out there that decide to change their socket fronts, please double and triple check your terminals and their tightness.
Go turn that power back on.
Flick it back on.
Oh, my wizard's going over there.
I'll be your apprentice.
John keeps turning my power off and it's doing my head in. The Wi-Fi keeps cutting in and out and I'm trying to work on my laptop. It's not going very well. Thankfully, I've got Tradify, which is today's video sponsor. I can work off my mobile phone, off my 4G, and I don't need a laptop. In fact, if you own a small business, like a trades business like us, you can literally run your whole business off your mobile phone. You can find out more about Tradify using the link below, get 50% off for 3 months using our special code.
That's back on for you, sir.
And look at that, Granny's happy now. Lights on, see in the dark without falling over this chair. It's great.
But now so now you've got the difficult job, Reuben. You need to explain to the customer that their electricity is unsafe. So you need to explain to me it's unsafe.
Right,
The stuff you have found in here, you're not happy with. And you need to convince me to spend more money on something that works and has worked for 30 years. That is the problem with our industry.
Okay.
It works. It works. There's nothing wrong with it. They're like, no, I don't want to spend any money, but it's dangerous. And this is the problem we have, because it all works. So why spend any money on it? Why get it inspected and tested? There's no point to it, but I'm a rich old lady, so I'm going to let you carry on.
Okay.
Your thing.
Okay, so therefore, well, I'm going to turn the power off now because I know that there's reverse polarity there and some grooviness in that socket.
Right, so you're going for...
So this socket, I keep on gravitating to this one. But it's this one.
Maybe that's your fault instincts coming through. You're
I know,
like,
right? I can
ooh.
smell it. I saw it in your eyes. Like, how does he know? I knew it.
Nobody's gonna know.
They're gonna know. Aha. L, N, but they're backwards. Boom shakalaka. I'll switch those back round. Revert them back.
So what Reuben's found there is cross polarity between the live and neutral. And the appliance will work the same if they're either way, because the way the electricity works, it cycles through. But if it was a single pole device, so if that was a single pole socket, you're effectively switching the neutral off. So a live would still be going into the appliance, but would have nowhere to go. And if it was under fault, the casing can become live on the class 1 equipment. Or if it was a fused spur, the same thing. If it's only switching the live conductor, it's actually switching the neutral conductor, which can leave it in an incredibly dangerous condition. So it's important we get that right. So again, if you are doing something like that, it may seem simple, but just doing one thing wrong like that can leave a very dangerous situation.
Time for a victory sip. Okay, so I found 2 of the faults, but because I know there's still some shonkiness going on, I'm going to revert back to my ring readings and just test the ring back from the board. Just take each leg out and test them individually. So because we've got a ring here, it means that we've got 2 cables at our breaker, meaning that one goes off, comes back round and comes back through the other one. So ideally, what we'd want to see is that when I put this on continuity and test between them, I should get a reading because it should be continuous all the way around. So if we don't, then we know there's a break in the ring somewhere, which I'll end up finding eventually, and yeah. Okay, so R1 first. We got nothing. That's always nice. Our neutrals. Okay, got a reading there. It's nothing. So let's have a look around, see what is happening, see if there's anything visible that could be changed. Sometimes they can be down. Aha. So now I'm getting a reading after flicking that spur, meaning that they've wired it the wrong way around. So with that on now, I'm going to test the other 2 as well, just to see if I'm either getting a reading from the earth, which I am not still. So it seems like there's a break in the earth, and there is still a reading on the neutral.
If you are working in a kitchen or anywhere with fused spurs, so Reuben works with me quite a lot, and it's something that we quite recently found on a EICR, and I flicked the spur, and it's obviously stuck with Reuben to find that straight away. So if you are getting a break in any of the conductors, double check that none of the fused spurs are switched off. And if you do, turn them all on, and then you start getting a reading. What's happened is what the fault I've put in here. And if it's left on all of the time, you're never gonna find out. So it's always worth operating your fused spurs on a EICR if you're doing the checks.
So what they've done is they've taken a leg of the ring and put it in the load side and put the live of the load side into the, what's it called?
Supply.
Supply. So I'm not getting a continuous loop, but there's still a feed going there, hence why it's working, but it's not right.
So you've got incoming and outgoing. This is where your ring's coming in, and then this switches up to this extractor fan. But what people can often do is confuse because there's 3 cables here and they're all the same size, and they get them confused. So I'm going to put this live in with one of these lives and move this live over to here. So what will happen, when this is switched off, it breaks the ring. And when it's switched back on, it makes the ring. Now, if I leave this in the off position when he starts testing, it should be a break and then we're going to see if Reuben figures out that if you turn that on, the ring's made again, then he should be able to come and check this to repair it. So what's happened there with Reuben, this is, a circle is easy to explain. So on this ring, there's going to be sockets all the way around it. So let's say we've got a couple of bits plugged in here, heavy duty. What will happen is current seeks the path of least resistance. So initially it's going to start coming around this way because there's less cable and less resistance to start powering these sockets. But what will happen is over time, and as the load increases, this is going to get warmer. As this gets warmer, there's going to get more resistance on it. So as it seeks the path with least resistance, this may be a better way round for it. So it's got two options on a ring to feed the same load. So what happens if you break that? It means that it's only one path. So this load is now, all of this is going down this one piece of cable, and this can start getting warm. And over time, it can only take about 27 amps at best, a bit of 2.5 on the ring, and it's protected by a 32 amp breaker. So this piece of cable is now the weak link in this circuit. So they don't, when they are broken rings, they can be incredibly dangerous because it's one big radial and it's not protected by the correct size fuse or MCB. So now this piece of cable is getting really warm. So if that fuse spur is switched off and lots is plugged in, one half of this ring is going to get incredibly warm, and that piece of cable is going to fail before the fuse does and potentially cause a fire. So it's incredibly dangerous having a broken ring.
Change that back now, so we've got two legs of the ring in the supply side as well as the neutral and earth, and then the load side is just the appliance going down.
So we just leave it hanging off for now.
So I've left that on. No, actually I'll switch it off now so that I know that the load is irrelevant to it. So we still should be getting a continuous loop between all of them. Well, not the earth because that's still broken, but at least between these two. See there, 156.
What's the significance between these readings, Reuben? Between the live and neutral?
They're about the same.
They should be the same.
Yeah. So because the live and the neutral are the same size cable and they go the same distance, so they got the same path, they should be the same resistance, or at least like the closest to it.
So test them again.
5.5, and on the neutrals 0.61 now. The neutrals are slightly higher.
Do you know what the maximum difference there can be between them? So if you get a reading greater than 0.05, you should really be investigating, or if it's fluctuating, which that appears to be doing. Bear in mind, I've put these faults in and it's incredibly difficult to simulate that fault. So
Yeah, right, okay, yeah. Yeah, it seems to be going up and down a little bit. So if I leave this with you, just have a look at this. What I'm gonna do is I'm gonna go around with a plug top and just wiggle all the sockets, and then hopefully we'll find, if there is a loose connection, we'll find it by wiggling it, because then the reading will jump up and down. So if you stay looking at this as I go round, jumping up and down.
Yeah. A bit.
Okay.
Yeah.
Right. Possibly a loose connection there. It's this one.
Well, it shouldn't be that one. I mean, that's off the wall, so shaking it's not going to do much.
True. Okay. This one.
No, it's staying the same.
Okay. And this one. Okay, so I suspect that socket there. I'm just going to whip this off, see if there's neutral either loose or fallen out or something like that.
I mean, the socket's not actually fixed back that well either, but if you have a look on that tester max, see it's ever so slightly fluctuating. Now, I find this all the time on EICRs, and actually trying to artificially create it is incredibly difficult, because normally a conductor's snapped and it's just touching, or the cable slipped out over time and it's just touching. But I must have spent 15 minutes trying to screw that socket back to simulate that fault. All the conductors are in. It looks good though, doesn't it?
Yeah, that's all right.
This one, I'm going to leave a loose connection, so these neutrals are completely loose. The tricky bit is putting it back and making it stay loose, because sometimes when you push it back, it gets a good connection again. That's great, right?
Looks pretty good. I mean,
check double check the cables.
Yeah, I'll just redo them. Loosen that up. Aha. So they've bitten down on the insulation, meaning that it's tight in there because it's caught in the insulation, but it's only just touching the copper inside, meaning there's a bit of a higher resistance. So I'll strip that back down.
It happens quite a lot, and what normally happens is the insulation stripped back. However, it's pushed in too far. It's not stripped back enough, and as it goes in, the screw then bites down on the outer sheath. So you'll get the socket working fine, but it would cause a high resistance joint. And what I'll show you later on is what a high resistance joint can do.
So I found reverse polarity there, neutral earth reverse there, that's 2. We found this spur being wired up wrong, that's 3, and a loose connection on the neutral, 4. So we've got 1 fault remaining, and it should be at that socket because I was getting a dodgy reading at it. So I'm gonna finish doing my ring readings and just see what I discover. As you can see, 0.55 on the neutral, and if we go back to our lines, we will find, hopefully, 0.55, beautiful. So that is crispy now, but as we saw earlier, we've got a break in the earth. So what I'm gonna do is I'm gonna make my figure of 8 with R1 and R2. So I'm gonna take the line of one leg and the earth of the other and link them together for both of them so that it's like a constant figure of 8 going round.
And what's the significance of that? What should your reading be for that figure of 8?
So what I should be getting for that is my R1 reading and my R2 reading divided by 4, because it should be split between the 4.
Yeah, so you get the same reading at any point on the. It's not always true in real life. In theory, it is. However, in a kitchen, you get build-up of moisture, cooking oils, and all sorts that get gummed up in sockets, and you won't get the same reading. It could be any manner of things. The plug, like a kettle has been plugged in for ages and it's damaged it. It never gets unplugged. All sorts of things to vary that. But if you read it actually on the terminals themselves rather than in the socket, you should get the exact reading at every single socket. But there's a little bit of fluctuation there.
It's essentially one big loop now. Then what we do, go around with our plug lead. In an ideal world, you'd get a reading at each one of these, but I know that's not the case. Good reading there. Here, hopefully bliss. Ah, bliss. All right. Bliss. Probably not bliss. Nothing there. Check these others. It should be okay because I was getting a reading for my live test. Just make sure. Okie dokie.
So why were you getting a reading? You're getting absolutely nothing on your Mega now, are you?
Yeah.
Oh, sorry, I keep pointing at Mega, your multifunction tester.
Yeah.
You're getting nothing at the moment on there, but you did get a voltage reading there, but it didn't bleep
That's
it yet.
right.
It didn't say it didn't say anything significant. If it doesn't have an earth, or what did it say when you tested it? It said con, didn't it? So it's saying it couldn't perform its test. You knew straight away there was something the matter with that socket. Yeah. But it's hard, it's actually really difficult to simulate these faults. The best thing to do would be move that socket off and see what treachery I've done, really, wouldn't it?
Yeah. Okay. So, look at that.
So what's happened?
Deceiving, isn't it? Looks, oh yeah, no, that earth's in there. Yeah, no, it's not.
Let's just pull the sleeving down. Because what can happen, well, you can see my hand, as you're pushing it into the terminal, you push the sleeving forward, and so the copper disappears. I'm going to pop it into here so it looks like it's connected, but they're actually not.
So, strip that back down. That hopefully is all fixed now. I'll quickly, because it's still linked out, I should be getting a reading here now.
Oh, you're getting
that. So, got our ring reading now. I'll just double check that there's one over there as well, a reading there. Hopefully there should be, and then we'll come back and do our live test. Hello.
What? You ain't fixed it, Reuben? What? What's going on?
Wait a damn minute. I'm sure I fixed that. Okay. Okay.
It's good, right?
Wait.
So what I always moan about you about these separate earths, I always argue you should put them both in the same terminal. So you've fixed one, haven't you?
Naughty. Okay, I see. So let's see if this one's okay. I was thinking, I was like, that's high. That
It was,
R1, R2 reading.
Yeah.
I was like 0.9 something. That doesn't sound right.
I pulled a little sneaky on you and put two faults at that one.
So if we run back over here, 0.87, which sounds about right. Because the earth is actually a smaller cable in twin and earth, it should be 1.67 times higher, I think it is, because it's 1/3 smaller than the other cables. Is that right?
It's a ratio 2.5. If you divide it by 2.5 and then times it by 1.5, you'd have, or vice versa.
What he said.
Yeah. So I moan at Reuben about these because it's a second terminal to make a muck up in. So you have 2 terminals for the earth, so you can come in and out in it. If you have lots of computers, you can have a clean earth on it. I keep rattling that. But I just find that sort of thing can happen more often. So people catch the sleeve in, so they get a high reading on the earth. I'd rather see them in the same terminal, in all honesty, if it's a ring, and you save that second one if you do have a fly lead to the back box or if you do have a clean earth on the system. What was it, 0.55?
Yeah. So
I've opened the calendar, so I've just absolutely biffed it there. Do it every time, 0.55.
87, I think it was, divided by 4. That should be our R1, R2 reading, about that.
Yep, and your earth, so if you do 0.55 times 1.67, the reading you get. So we're a little bit lower, but this can be parallel paths on the circuit. So the one fault that was found at this socket here was a loose connection on the neutral. So I've just left that loose connection in there. So it's just about touching. And to me, this is one of the most dangerous ones here. This is the one that's going to catch fire and you're never going to know about it until it's too late. So this will sit there minding its own business and everything would still be working. However, as the load increases, this may cause the loose connection to arc under load. So what I'm going to show you now, we're going to put on a couple of heavy duty irons, the iron and the kettle, and have a look at this with its unscrewed, just to show you what's going on behind. That could be happening in the back of any one of these sockets as a loose connection, or multiple of them on the line or neutral conductor, and it's just going to sit there over time, and as you plug things in, slowly melt away until it causes a fire. It's so dangerous. So Reuben's done a fantastic job there. I'm really proud of him. Naysayers in the comment might think that I've told him the faults beforehand, but it's really not the case. But this is just to show you guys that electricity you can't see it, can't hear it, you know, it's there, it's invisible, and it's doing its thing. Everything here was on and working when we came, and it was in a dangerous condition. So it's just trying to get across to people that the importance of electrical maintenance and getting your property tested, getting competent people to do the work as well, because you know, it only takes one little mishap. And even us as qualified electricians, it's double and triple checking your work. If you do work on the tools, make sure you're double and triple checking your work, because it's so easy to make a mistake. And yeah, just proud of Reuben. Great job.
Okay. Thanks for watching, guys. Thanks for watching, guys. Hopefully you guys learned something. I definitely did. It's really useful getting my hands on the tools with regards to fault finding. So if you get the chance, definitely try it. Anyway, I'll catch you in the next one.